Hello, we're on to video number 2 now. So just trying to summarise some of this quickly. With a regular normal distribution question, we start with our x value or our measurement. Put in x, and we end up producing a probability. Just fill that in. And the way we are generally going to be doing that is by using the normal CDF function on our calculator. This is the cumulative distribution function. When we do the inverse normal, we're doing the opposite. We're starting off with this probability. It's going to fit just about. And we're going to produce an x value or a measurement. And in order to do that, we're using the inverse normal. Both of these are found in the distribution menu of your calculator, where we're also using the binomial distribution functions as well. So let's look at a few more examples. From these ones, we're looking at finding a, but we have, instead of x, we have z. Z means our standard normal distribution. That is, it has a, so z, it's our standard normal distribution. It has a mean of 0 and a standard deviation of 1. It's our standard normal distribution. Other ways of solving normal distribution problems without a calculator would involve turning all of our x values into z values, so finding out how many standard deviations we are away, and then looking up those values from tables. Fortunately, we don't have to worry about that. But we should know that if we see z, we're talking about this standard normal. As you can see, none of the mean or standard deviation information was given here. So let's have a look at doing these. As my drawings so far have been terrible, I'm going to start cheating a little bit and using some that have already been made for me. Right, so there's my curve. I know, as this is the standard normal, this point here is 0. We're looking at a probability that z is less than a is equal to 0.922. That's right the way up here. Remember, our probabilities go up to add up to 1. So we're looking at a lot of our curve. A lot of the area under our curve anyway. And this is our value for a. So I can just go to my calculator. Once again, apologies that this looks slightly different to yours. Yours is much easier to use. Your first menu is the area. We know that the probability is 0.922. We know our mean is 0 and our standard deviation is 1. Okay, and we've stated that up here. So there we go, there's our a value, 1.42. So if we were making sure we're showing our workings correctly, we would have this, we would have this that was given to us, and then we'd have our answer. Thinking about this, does it seem sensible? Well, we know one standard deviation is 68% of our population, 2 standard deviations is 95%, and well, I'm not quite at 2 standard deviations, but I've got all of this lower 50% here, so this sounds reasonable. Right, let's move on to B. So I'll need another graph. In fact, I'm just going to rub out this so I can use it for B. B, a slightly different inequality. Here we know the probability that z is greater than a is 0.342. So that's my mean. Z is greater than a, the probability is less than a half. So if it said z is greater than a equals a half, I'd know we're talking about the middle. So I've got to be a little bit further across. So I'm going to go for here. This is my a, This is the 0.342, and it's useful to know what this value is as well. So this is 0.658. Remember, they add up to a whole. Our inverse normal function only works counting from the left. The regular normal function, we've got quite a lot of flexibility. We can count from the far left up to a point, from a point up to the far right, or any range in between. The inverse normal's slightly more restricted. So rather than thinking about this probability, I'm just going to state this in a slightly different way. So the probability that z is greater than a is this. The probability that z is less than a, I also know. So that is this probability, 0.658. So we can go to our calculator, we can enter it in, and I want the inverse normal, the area 0.658, the mean is 0, and the standard deviation is 1. There we go, 0.407, so A equals 0.407. That looks reasonable. Okay, moving on to our last one. Okay, we're going to have to think a little bit more about this notation here. So we're saying the probability that the modulus of z is less than a. So if it had just been the modulus of, if it had just been the probability that z is less than a, well, I think that would be very similar to this problem here. What we're thinking about now is the modulus of z, so we've also got to consider the negative. So if this is a, this would be negative a. So now the size of z is smaller than a, so I'm looking at this area in the middle here. Okay, so this area is worth 0.4. So it's symmetrical, which is good. So I've got 0.2 on either side. I know that this area here must be 0.3 then. So 0.3 and 0.3 would add up to a whole with this area in the middle. So I've got a couple of options. I can count up to negative a and say that my area is equal to 0.3, or I could count up to positive a and think about all of this probability space. So this probability space is 0.3 and 0.4. So I think I'm going to go for that. Then I don't need to worry about any negatives. So the probability that z is less than a is 0.7. So what is a? Back to our inverse normal function. So 0.7 is my area, my mean is 0, my standard deviation is 1. And we get 0.524. So slightly tougher problem, you have to think a little bit more about it. Drawing a sketch is always helpful, and I strongly recommend you do this for every single question. Reminder, we should also have what distribution we're using and the details about it, and it's always the mean and the variance. Right? Obviously for our standard normal, our variance and standard deviation are the same, so that's kind of handy.